Just kind of an introduction, everybody. My name is Zachary Mulcahey, and I work with CodeVA. I have been working with CodeVA since their early start in 2014, and since 2016, I've been running their robotics program. I have experience with FIRST Robotics through my first year running their team there, as well as in high school when I was a junior and senior. My senior year, I was the captain of our FIRST Robotics team. So this has been really cool, getting to kind of dive back into the world of FIRST. At CodeVA, we moved over to VEX Robotics. So I'm excited to share just kind of a basic intro on how to get ourselves set up and how to program our first robots with Java or C++. And I have a slideshow I'm going to share, and we're going to walk through that as well as take a look at the actual software that we're going to be using to program in Java or C++. And I just want to say off the bat, please feel free to use the chat or unmute yourself and ask me a question or ask me to re-explain something. And if you want me to go in more detail on something, this is an hour session. So I tried to keep it to an overview while covering the important parts. But if there's something you want me to dive a little more in, since we have a smaller crowd, I think that would be totally fine. So just right off the bat, what are we going to be doing in this session? So kind of our session overview. We're going to be providing an introduction of using Java and C++ to program robots for the FIRST robotics competition. Pretty straightforward. So first off, we're going to discuss the pros and cons of using Java or C++ versus something like LabVIEW or Python, some of our other programming options. I'm going to provide you all with some resources onto how to prepare the robot Rio to be programmed in Java or C++. There is some preparation that we have to do. We're going to go over the basic structure for how a robot is coded with Java and C++. And at the very end of the slideshow, which I'll be providing to you all after the session, is additional resources for students and coaches. So it's kind of some technical stuff, some videos, just hopefully some more material to get you moving further along. So I did have a poll that I wanted to have everybody do. It's pretty simple, just whether or not we have programmed FRC robots. Sorry about that. I don't know if Zoom just popped for everybody or just me, but my Zoom just reloaded for whatever reason. Okay, so we have not programmed FRC robots before. No worries. There are so many awesome resources out here that will allow us to get a really good start and to help out getting started. Let me reshare my presentation. Sorry about that. I don't know why Zoom kicked me out. So kind of just an overview. Why am I bundling Java and C++ together in the same 1 hour session? And the main reason is they're both very similar text-based typed languages, and they're both used in many real-world applications. So especially for the students going through the robotics program on your robotics teams, both of these languages can be really valuable in building skills past FIRST robotics. That's not quite the case for something like LabVIEW. LabVIEW is designed to be pretty specifically applied to FIRST robotics competition. But students who are spending time learning Java and C++ earlier on are going to have a leg up if software development is where they want to head in life. Both Java and C++ are object-oriented languages. Now, if you're not too familiar with programming, I wouldn't expect you to know that phrase, but kind of the big idea around an object-oriented language is it's broken down into the smallest possible pieces that can be used to write a line of code. So it's meant to be particularly easy to wrap your mind around. Both languages start their code from the main method in the code file. And that main method is where our kind of the heart of our code lives. In C++, it's at the bottom of our file, and in Java, it's actually a completely separate file. And that's the code that the robot Rio is going to look for, that either main.java or robot.cpp, and it's going to look for that main method to kind of start the code out. So they both use that same way to start. And both use the same structure for comments. And just to kind of a little bit in comments, while you're coding a robot, especially something with kind of some abstract values, it's helpful to add comments for other people to look at your code and understand what you've been writing. For those just joining, my name is Mulcahey with CodeVA, and we're just getting started kind of talking about the similarities between Java and C++ and why I've lumped them together into one training. At any point, if you have any questions, please feel free to use the chat or unmute and ask them out loud.
Thank you, Zach.
Alrighty, so getting into the differences, because they're not the same language. The biggest difference between Java and C++ at a technical level is that Java is an interpreted language and C++ is a directly compiled language. And all that big mumbo jumbo basically means that Java has an extra step before the computer hardware actually does anything with it. And that can have some benefits and it can have some drawbacks. So just to kind of go into the definitions, Java being an interpreted language means it's converted into bytecode that runs inside the Java virtual machine, while C++ is compiled directly into machine code, which is super low level, kind of think ones and zeros style coding that actually tells the hardware what to do. And the kind of biggest benefit and drawback we see from this big difference is that Java is usually a little bit better at telling us when we're trying to run bad code or when we're typing up bad code, because it has to go through that step of being converted to bytecode before the machine can even run it. And if there are errors in that conversion, Java, the IDE, will tell us this code is no good, you need to fix these errors. C++ is a little messier. It can compile improper code directly and lead to issues at runtime rather than when you're trying to compile it. But on the flip side, C++ can handle complex math much faster than Java. And now I don't know how many first teams are actually doing really crazy mathematical functions. I'm sure some with the laser tracking of projectiles are really having to do a lot of math. And in those cases, C++ would probably be a better choice. And that last kind of difference there, C++, being such a low-level language, is able to directly manipulate memory, which can be useful in limited scenarios, but more often than not, when you're using C++, if you are not very confident in your code, it's possible to write more errors and to get a little more lost because it's such a direct controlling language. The kind of note for Java is Java has a feature called garbage collection. And that's just kind of a fancy way of saying when you're done with data in a Java program, Java knows how to handle that. Because C++ directly manipulates our memory, if we don't clear it out manually, we can overflow it and cause a crash that way. And similarly to the last kind of step talking about Java and C++ being industry languages that can build future skills, Java is used for the AP Computer Science exam. So if any of your students are going to have the opportunity to pursue AP Computer Science, focusing on Java in robotics could again give them a huge leg up in that skill. So before I get kind of into the actual programming and setting up with Java and C++, does anybody have any questions on how they're similar or how they're different?
No, sir.
Okay, awesome. So moving on, the robot Rio is the brain of our first robot. Now, in kind of prepping for this, I know that there is a new, I think it's the Robo Rio 2 that is recently launched. Because that was deployed this year, I did not include setup instructions for that. If your team has a newer Robo Rio and you'd like some support material, please reach out to me and I'd be more than happy to help you with that. But this is for I guess the last generation Robo Rio that I think most teams will be operating with. And so the first step is to install FRC Game Tools. And FRC Game Tools is listed on this website here. And it's a very simple program to install. This all walks you through it, so I'm not going to spend too much time going through all this. It's very straightforward, and all the links are listed in here. The only caveat, I know a lot of schools have transitioned to using Chromebooks for a lot of computing. FRC Game Tools is only compatible on Windows machines. So if you are using non-Windows computers, you'll need to either find a workaround or a Windows machine to access. And then similarly, after we install FRC Game Tools, that's the software we're going to use to prepare the Robo Rio. And again, I have a guide attached here. It has nice diagrams. It tells us everything we need to plug in and where and how we image it using FRC Game Tools. And it's a very straightforward process as long as you follow along that guide. And again, if you're using a newer Robo Rio and that guide's not applicable, reach out and I can do whatever I can to help you get that set up. And just for context, that linked guide assumes a properly powered Robo Rio. So that means set up with the power board for the first robot and wired up with the 12-volt battery. So you can't just plug the Robo Rio directly into a computer and get it all set up before it's kind of powered by the robot itself. Okay. And so then setting up Java or our C++ environment for the Robo Rio actually utilizes the same couple of steps for the first few bits. So we're going to be using a program called VS Code, Virtual Studio Code, and all of the code that we need to play around with motors and sensors and the joysticks and different first robot parts are in this WPI library. And this WPI library is an amazing resource. I'd list it at the end of the slideshow as the best resource. It has tutorials for everything. It's where those two guides that I linked in the previous slide are from. And it can really walk you through just about anything you need to do, simple to advanced, with your first robotics robot. I went forward one more. And so Visual Code Studio is what's called our IDE, or our Intelligent Development Environment. And so this is the piece of software that will allow us to type in our Java and C++ code. It's what we'll use to deploy it to the robot, and it's what we'll use to do bug tracking and figuring out errors. And I'm just going to show you all this guide page. This software can be installed on Windows, Mac, or Linux machines, so it's a little more versatile than the FRC tools. So students can write code and send code to the robot from different machines. But this is a fairly straightforward installation. Again, another guide. But the important part is down here at the end, they give you one last selection where you can choose what you'd like to install. If you know your team is only going to be using C++, you could uncheck the Java option here. And if you know your team is just going to be using Java, you can uncheck the C++. And that'll help keep the software cleaner and more focused on your team's needs. And so once installed, you would go ahead and open that application up, and I'm going to go ahead and share that application as well, so I can kind of walk you all through what it looks like and how to get started with it. Okay, so this is Visual Code Studio, and this is the package installed with that WPI library. And here's where we would kind of set up and get our basic programs ready. So I'm going to go back to the slideshow to kind of talk about how we would go about doing that. So at this point, because there are some differences between Java and C++ in the setup, I'm going to alternate talking about Java and talking about C++. I can understand that can get confusing. So if I need to slow down, or if you would like me to stick to just the Java stuff first and then cover the C++ differences, I can do that. But feel free to use the chat or unmute and say, hey guys, slow down. I don't understand. But I'm going to get started with talking about our Java layout. So in our newly installed software, there's actually a whole new project generator. And that allows us to kind of simply create a project that allows us to get coding really quickly. So notice I say we need to click on the WPI library button. And that's going to be up in the top right. And it's going to give us some options to create a new project. So I know it's really tiny and probably hard to see. I tried to blow up the picture a little bit, but it got too pixely. It's this button up here in the top right. And when we click on that, it opens up this command palette. And I've recently used it, so it's right at the top. But you might need to scroll down and find create a new project. And this is a wonderful program. It takes us through getting us the basics of what we need for our Java or C++ program. So right off the bat, we need to select a new project folder. I'm using an old Zoom folder on my computer. And this project name is going to be Java example. And we're going to be team 4 zeros. So you can fill in the basic information, and that's for helping you keep track of your different projects. As different students are wanting to learn programming and wanting to explore different sensors and different motors, it makes sense to create entirely new projects for that, so you can keep your main robot drive code nice and clean and separate from experiments. So once we have our basic data filled in, we can use these buttons at the top to kind of select how we want to get started. Built in, there are I think about a half dozen examples and a half dozen templates. The examples are going to be more fully featured bits of code that you could actually run on a properly configured robot. And the templates are going to allow us to have a framework to fill in for our coding needs. So I'm going to start with a template, and we're going to kind of work through that and see how it looks as an example. So we're going to go with template, and I want to select Java. Something that can be a little confusing about C++. Some people write it as the letter C and 2 plus signs, and some people write CPP. So it can be a little tricky just to, I don't know, find it sometimes, but make note of that. All righty. Oh, I seem to have lost my window. There we go. Okay, so we select Java. And I'm going to use timed robot. And the reason I'm using timed robot is it has all the main pre-built-in functions that we would ever use in a first robotics competition robot. So I can kind of talk about those and what they're used for. And so once we select our project base, we can come down here and click Generate Project. It's going to say would we like to open the folder, and I would like to in the current window. And it's going to take a second and pop around. And then we are in our Java example code. So down here at the bottom is our terminal and our debug console. I'm not really going to be diving into that today, but the WPI library has great resources on how we would use that. So the layout for all of our projects are going to have a whole bunch of files, but the main ones where we're going to be writing our code are going to be in this source folder. And so we're going to go to source, and then we're going to go to Java. And I'm going to switch on back to our slideshow to kind of talk about some of this stuff. Okay, so with our project continued, we have the files created main.java and robot.java. So those are those two files that the robot's going to look for to figure out what to do. And that's where we need to have our code to live. The main.java is a pretty simple file. And unless you're making some pretty advanced robot programs, you're not going to touch it very much. The main.java file exists to tell the RoboRio to look at the robot.java file. And the robot.java file that we're using with the timed robot template includes all of the main functions. And the functions are where our code needs to go. So I'm going to go to our next slide, but I want to ask a question. Oh, wait, actually, sorry. The differences with C++, my apologies. In C++, we only get a robot.cpp file. So it's a little simpler to work with, and we just don't have to worry about having that main file to accidentally be editing. But that's really the only structural difference in how the two files start. So here's a list of the basic RoboRio functions. And before I dive into all this, I want to ask you all, when I say the word function and referring to program, does anybody know what I mean? Or should I kind of talk about that a little bit?
You can give a brief overview.
Okay, awesome. So a function is kind of like a pre-built piece of code that can be predefined and called upon to complete a certain action. And so thinking about robot programming, if we wanted to be able to press a button and have our robot arm, reach forward, grab something, move up, and let go, those 3 steps we would program into a function that we would assign to that button. So a function is kind of like a listing of code combined under an easily referable name. And with our RoboRio, if we're in Java or C++, we have 8 primary functions. The only difference between Java and C++ is how they're typed. They have different capital letters or different punctuation, but they function the same way. So thinking about a first robotics competition, we have the moment where we put the robot on the field and it's turned on. That would be the robot initialization. And that's what this first function here is. That's what that stands for, robot initialization. And so any code that we write into this function is going to come on as soon as the robot turns on and reads its code file. So that could be something like blinking the LED light. It could be something like playing a fun startup sound. But for the most part, when we're in a competition, we want to use this one over here called teleop initialization. And so this is the code that would be called when it is put in teleop mode. So that's where we'd want to put the code that lets us drive around with the joystick, or where we'd want to put the code that uses our fancy laser sensors to track things around the field, all sorts of things like that. There's also an autonomous initialization function. And like the name says, that's the code that'll run when it's in autonomous mode. So for that first portion of the competition, when it's in autonomous mode, your code to have the robot drive forward a set distance and to rotate at a set angle, that would all be in the autonomous initialization code. And there's also a test initialization code. You can put your RoboRio into test mode, and that'll allow you to test out different codes and functions. And that's where that code would be called. Now, if you notice, all of these also have a periodic function along with them. So this first one, second one on the left, robot periodic. Any code that's inside this function will run by default every 20 milliseconds. So that would be a great place to put on blinking light code. You could turn on an LED and turn it off every 20 milliseconds, and that would give you a pretty good flashing light. And the autonomous and teleop periodic are, it kind of depends on what you need your robot to be doing. If you are using a sensor to track data, but you don't always need that data coming in, overloading your robot, you might read the data in the teleop periodic function rather than in the initialization function. So it's only checking every 20 milliseconds. But the functions are the heart of our program. Everything we put in these codes are what the competition control systems are going to call on the Robo Rios and have them do when it's time. And switching back over to our Java example, I'm going to show you all how these functions look in our timed robot template program. So as I said, our main.java, pretty light. All this stuff here that is in green are comments, just kind of explaining what this file is and why it's here. But the only code we have right here is robotbase.startRobot. And that is just calling our Rio to start the robot using robot.java. It's a little, programming syntax is a little confusing. You end up using a lot of the same words repeatedly. But in our robot.java is where we have all the good stuff. So if I come on down here, you should all be able to see, and if this text is too small because I'm screen sharing, somebody pop it in the chat. But here we have our robot initialize. So in here between these two brackets, notice our software is highlighting those nicely for us, is all the code we would put for that robot initialize function. So that's stuff where we could put, as soon as the robot's turned on, this is what we want it to do. And I'm pretty sure, yeah, so these just kind of default some options on the Robo Rio. Yeah, because this is our template file. And if we come down here, notice there is our robot periodic. So that's that one that'll run every 20 milliseconds after we turn the robot on. Whatever code we put in here will run. And again, all these comments are really helpful. They can help you understand some different things, tell you what the functions are there for and how you can use them. Here's our autonomous initialization, pretty straightforward. Again, just kind of doing some default stuff. I think this is check. Yeah, this is a mode checker. So it's checking to see whether or not it's in autonomous or teleop mode. And as we go down the file, we can see we have all of those main 8 functions: autonomous periodic, teleop initialization, teleop periodic. Okay, they do have disabled in here. So you can have code run when your robot's told to stop doing stuff. I didn't think that was super important to include in the slideshow. And then we have our test initialization and test periodic. And so this is where all the code for our robot would actually live. And the first step that we have to do is we need to import libraries. So Java as a language and C++ as a language don't know how to control motors. They don't know how to talk to joysticks. They don't know how to deal with sensors. And that's where this WPI library comes in so handy. WPI library is officially partnered with FIRST and has developed all these libraries to talk with the official FIRST and FIRST supported parts. And so we're going to kind of talk through a simple example and also code through it in our software through the layout for a differential drive robot, that is teleoperated. And to talk to our motors and to set up a pre-built drivetrain, we need to import some libraries. And all libraries are existing code files that we can use to add functionality to our programs. Almost every library you're going to use for a first robot is going to come from WPI libraries. And down here at the bottom is an example of the 3 libraries we would need to talk to our joystick, to set up a pre-built differential drive, and to control our motors. And so notice, some like the joystick, that's pretty straightforward. That says exactly what it means. But PWM Victor SPX does not immediately scream motor, at least to me. So paying attention to how things are typed and spelled are very important. And all of this stuff is included in the resources section I have at the end. But so to get started, I am going to import these three libraries into our example program. So notice this already has some imports pre-built, and all of our imports go up at the top of our code. And importing in Java is pretty simple. I'll just start a new line and type the word import. And like I said, almost all of our projects are going to be coming from this WPI library. So we can kind of get through there and fill in along. Notice that we're getting all sorts of suggestions from our IDE. The software really wants to help us not type out all of our code by hand. And I think I need joystick, drive differential, and motors. Okay, so notice it shows up, and an important thing in Java, and not the case in C++, is semicolons. We need to end all of our lines of code in semicolons. Your IDE will help you do that a lot, but if you're running into an error and you just can't figure it out, double check that semicolons are where they need to be. Okay. Alrighty, and now I'm adding in the differential drive, which kind of is pre-built stuff to help us deal with two motors at once. Okay, and then there's our weirdly named motor controller. So in just those 3 lines of code, we've now set up this file to be able to talk with the joystick and to be able to handle motors and to be able to set up a pre-built drivetrain. So once you're actually in doing the code, it's relatively quickly. It just takes a little bit to kind of get set up and get started. So since we want to have this happen in a teleop sense, we want to be able to control our robot in this example. We're going to scroll down to the teleop initialization section. And we're going to add some space between our 2 brackets so we can add some code in there for when our robot would enter the teleop period and be able to talk to its joystick. And I do apologize because I'm sure this is going to be a little harder to read. This text was just small and I wanted it to all stay on the same line. But down here at the bottom are how we actually set these up to work with our code. So we added in those classes that let us talk to motors, let us set up a pre-built drivetrain, and let us talk to the joystick. But we need to actually use those and assign them in our code. So once we've imported all the libraries we need for our code, it's time to create some variables. In order to use any of these features, they need to be assigned to a variable so we can actually complete an operation with them. In this example, we're going to assume 2 motors on ports 0 and 1 and a joystick on port 0. And it'll just kind of allow us to get pretty straightforward. So I'm going to go back over to our Java code because I think we'd be able to see that a little better, but I am going to set up our variable for our drivetrain. So here in our teleop initialization, this is where we want to put anything that happens when we want to control the robot with the controller. We want to start by making a private variable, and that's really just means that it doesn't exist outside of the teleop initialization function. So if I wanted to make a variable of the same name in a different function, I can because it's a private variable. And we're naming it final because we do not want any changes to it after we create this variable. And then we're going to refer to that class that we added, which was the differential drive. And notice again, it loves to fill in all the blanks for us. And we are going to name our drivetrain. We're going to name it M_robot drive. And the main reason I'm naming it that is it's a kind of a pretty standard convention amongst all of these tutorials. So I just want it to seem a little familiar. So we've said we're making a private variable. It's final in this function, and it's based on the differential drive class, and it's named mRobot drive. But what does this variable actually hold? We're going to type in an equals sign, and we're going to set this variable, our drivetrain, to hold those two motors that are on port 0 and port 1. And so the way we do that is we're going to call the differential drive class again. And then we are going to add two parameters. Parameters are anything that go in these parentheses next to a function that are allowing you to pass data into the function. The differential drive class sets up handling for two motors. We just have to tell it where those two motors are. Because we haven't assigned this yet, we type in the word new. And then we need to select that oddly named motor class and pass that some data in the parentheses to let it know we want to refer to the motor on port 0. So we see it here. And we notice that when we click it to fill in, it's got that highlighted section saying channel. And so that's where we would put that 0. That's where it's located. Since our differential drive has two motors, we need to use a comma and add in our second one. Following the same structure, except this time selecting port 1. And like everything in Java, we need to end it with a semicolon. Okay, and believe it or not, we only have one more line of code to write before we'd have a fully driving robot that we could connect around with or drive around with the joystick. So we need to make another private variable. Sorry, another private final variable. And we're going to call that joystick class that we'd called up there. And we're going to name this one m_stick. It's going to equal a new joystick. And our joystick is at port 0. So just notice as I'm going through here, I'm having to capture a lot of detail with this code. I'm not just creating a variable, I'm creating variables with specific classes and specific data that's based on how the robot is physically put together. That's one of the reasons why programming is a harder thing as you're a little further away from the build. Okay, so those are our two variables. We've set those up and they are ready to go, assigning those classes properties to that data that we've pulled in. And then we are just one line of code away from having our robot ready to drive. So as we set up our drivetrain up here as mRobot drive, that's what we're going to call now when we want our drivetrain to do something. That's the name we gave our drivetrain that we set up. So we're going to call mRobot drive. And notice again, it likes to fill in everything, even if it's something we added. Now, inside differential drive, there are different functions for kind of different ways to handle two-motor driving. And the one we're going to use is arcade drive. Notice they both pop up right down here for us. So we are going to do arcade drive. And we're going to add in two more parameters. So our joystick is going to be giving us an X and a Y variable that we can read at any time. The X is going to be how far left or right we're swinging the joystick, and the Y is going to be how far forward or backwards we're pushing or pulling it. And we're going to pull in that data from the joystick to control our drivetrain. So we named our joystick m_stick, so that's what we're going to call here. And then we're going to do something to call a function in the joystick class. We are going to use the .getY function, and that's going to pull in that Y variable data from our joystick, how far forward or how far back it's being pulled. So we type in our variable name, and then notice all of the functions available in the joystick file come up as an option. And so we're going to use the getY. And then we need to delete this pre-built code here. And we need to add in our X variable so our robot is responding fully to the joystick, not just forward and backwards. And believe it or not, that is, oh, I'm sorry. We need to set, oh no, we don't. We don't need to set a number here. We did it up there. Cool. So that is it. That is the entire 3 lines of code we need, along with the 3 libraries we imported at the top to set up a 2-motor robot to drive around with the joystick. It's pretty straightforward. And the biggest thing is just kind of getting used to how to use the code and how to reference things in the way the code needs. It's just an interesting learning curve. And these resources that I've provided will be really helpful for just kind of referencing and making sure we're typing things properly. It just takes a lot of practice. Okay, and so now that we've kind of walked through that basic code in Java, I kind of want to talk about some of the differences we have with C++, and see if you all have any questions with that Java example. Okay, then I'm gonna hop back to the slideshow and just talk about some of the differences between how we would do that exact same thing in C++. It's still pretty simple code. So one difference is how we import or include libraries. So in Java, we import libraries by literally typing in the word import and then typing out the big long string for exactly what our library's name is. They're all listed in documentation files, so they're not necessarily too hard to find, but it can get a little confusing looking at those big long strings of text. In C++, the libraries are a little bit simpler. They are included instead of imported, a slight difference, but it makes all the difference when you're typing it up. So those same 3 libraries would be imported by using these 3 simpler, much shorter lines of code than in Java. The way C++ is structured, all of the additional libraries are just included in an FRC folder. So it makes it a little bit easier to select and to kind of look at what libraries you're actually using. And the variables in C++, again, are a little bit simpler, but not all that different. So in Java, we were able to set up our drivetrain in 1 variable. We have our differential drive set up, we name it robot drive, and we attach both of our motors to it, all in the same line of code. In C++, we have to break that down. We have to set our motors. We have to name 1 motor left motor, 1 right, and then we have to set up the differential drive as a completely separate line of code attaching our left and right motors. So just a little difference, but it all matters when you're typing it out, and whichever one you're used to or comfortable with. And then it's a very similar setup for the joystick. You'll notice that the Java variables, and in general, Java is just a little wordier than C++. There's a little more text. And again, the teleop code for this, this is where we see one of those, I'd say, more tedious differences between Java and C++. We have a very similar mRobot drive. We use the same variable. And we used arcade drive, but in C++, both the A and the D in arcade drive are capitalized. In Java, it's just the D capitalized. And the main reason I point that out is if you are starting to use one language and try to move to another, it can be a little frustrating to kind of get used to those changes. Notice the same thing, the get Y and get X, both the G and the Y and X are capital. In Java, it's just the Y and the X. So it's not too different from an understanding level, but applying it, there's slight enough differences that it's important to be paying attention. And so kind of the big takeaway for Java and C++ over like kind of against each other in the first robotics competition world is syntax. If you have any student or any coaches or any mentors that has experience with Java or has experience with C++ and they're comfortable working on it, go with that. There isn't a huge enough benefit for C++ or Java programmatically unless you are working on really complex robots, which I really hope you are. But until you're getting to really high level coding and really dense math, you're not going to notice too much of a difference in how the Java code or how the C++ code runs. So kind of just, you know, whatever works for your team. If you have anybody with experience in any of these, that's kind of your best bet for kind of a path to start. And then additional resources. So the best resource, this is that WPI Libraries website. They literally have every single thing I covered, a lot slower and a lot denser. There is everything from getting the software set up to programming the robot, how to wire your robot, and all sorts of stuff. There are advanced programming options, how you do vision processing, doing network tables, all sorts of stuff. Also on that website, but it's a little buried, so I included it specifically. There are coding resources for new students. So these are kind of meant for anybody who hasn't touched Java or C++. They do list LabVIEW here, but that'll be another training. Excuse me. And these are, from what I understand, free trainings that can be both for students and adults, just to get used to Java and C++ programming in general. Excuse me. These trainings do not focus specifically on first robotics programming. So just keep in mind, it is a little bit of a jump to go from generic Java or generic C++ to robot Java and C++. Just a little bit more advanced. And if you or your students are visual learners, First Robotics Canada has actually put out a wonderful video series. It's 8 separate videos. First one kind of going through what I just went through and also going through the making a simple drivetrain, all the way through introduction to pneumatics, using motors for a subsystem, ultrasonic sensors. They're pretty good videos. They're from last year, so the content should still be pretty up to date. But yeah, there's definitely a good resource there. And wow, with just a few minutes to spare, that is actually my presentation. So I would love if anybody has any questions or comments or thoughts. I'd love to hear those.
Thank you, Zach.
Yeah, I'm glad I could. I'm glad I could provide some resources. I'm gonna send you this slideshow so you can share it out with everybody. Is that okay?
Yeah, great.
Awesome. Cool. Oh, is there a chat?
Yes, thank you. It was very informative.
Yeah. Thank you all for attending. And again, I'll make sure to provide my email as well. If you all have any questions or just, I don't know, general concerns, feel free to reach out. I'm getting to kind of refocus my whole new year on robotics of all sizes. So I would love to be a resource to anybody who needs it.
Awesome. Thank you.
Yeah. Thanks, everybody. Bye.
Thank you. Thank you.
Thank you.